Hey guys, it's Brandon here from microscopeclarity.com. Today we're going to be going over numerical aperture. So numerical aperture, it's a little bit of an intimidating topic just because there's some math involved. Some people kind of shy away from it, don't really learn and understand what it means. And there is some nuance and technicality to it that we're not going to go through today. I just want to go through the basics just for the amateur or for the kind of hobbyist or enthusiast to understand what it is. So numerical aperture is really just the objective lens ability to collect light. That's all it is. And then light, that ability to collect light is going to basically determine or have a lot to do with the determination of how well an object can be resolved that we're observing. And so numerical aperture is expressed in an equation. So you have theta, which is just the acceptable angular aperture. It's typically, I've heard it referred to as half of the angular aperture. And I'll explain what that actually means in just a second whenever we look at the microscope. So you're taking the sine of theta and you're multiplying it by the refractive index of the medium under which you're observing the specimen. And so typically, if you're not using any immersion oils, the medium is going to be air, and the refractive index of air is 1. So let's take a closer look at the microscope and let's understand what this concept actually means, because it's a little bit abstract and it's really hard to understand unless you actually take a look at it with the microscope. Okay, so here's the microscope, and we can see here on the objective lens, so this big number is going to be your magnification, and then your optimal numerical aperture for this objective is going to be right after the slash there. So this is 0.25. And remember the calculation is we take the sine of theta, which is half of our angular aperture, and we multiply that in this case by 1 because our refractive index of air is 1. So let's take a look at what we mean by theta in this case. So I have the microscope on, and so you can see that there is a cone of light there, and as I increase, or as I open up the iris diaphragm, I start to get this cone of light that I can adjust here. And you can see that the angle there, and so we're starting from that midline there and then to the right because we're taking half of that angle. So this really, so as we open up the iris diaphragm, our angle increases. Okay, so closing and opening, and now your condenser should have settings there where you can actually, adjust it to a specific numerical aperture. But this is just for illustration purposes, just to show you, how the angle of the cone of light changes. So, you could, you could take the angle here and then you could plug it into that formula and calculate numerical aperture. So that's really all there is to numerical aperture, at least from a basic standpoint. There's definitely a lot more to that, and there's a lot more resources that go into a lot of that detail. But if you're just starting out, this is really all you need to know, and I hope that was a pretty decent explanation of it. So down below there is an article that goes into much more detail, so if you want to take a look at that, check out that article. If you like this explanation, like, subscribe, and share, and we'll see you next time.